All right, so our last thing for today, last lesson for today, we're going to be looking at what's called an arithmetic series before we did a sequence. Now, here's the difference between the two. Nothing too crazy is that an arithmetic sequence, which we did the first two classes today, is just a list of numbers, just a list. So you have a number, comma, number, comma, number, comma. Doesn't work like that with a series. Here's what a series is all about is we have this thing here called S of n, big capital S of n. And notice there's no commas in between the terms, but there's in fact plus signs. So we're adding them all up. So this S of n here is the sum of the first n terms. So you can add up the first 5 terms, the first 10 terms, the first 100,000 terms. It doesn't matter. But now, so now what we're looking at is adding up all those terms, not just figuring out which terms are where. And so there is a formula. I'm going to write it over here. I'm going to switch up the color. Let's see here. So I have S of n. So that is the sum of the first n terms is equal to n, the number of terms you've got, times 2a plus n minus 1 d, n minus 1 times d. And down below, we're going to take all that and divide it by 2. All right, so there's another formula for us. Again, the difference between a sequence and a series. A sequence, you're listing the numbers. A series, you're adding them up, not only just listing them. All right, so when I look at example number 1. All right, so here is our series. So again, we have 2 plus 11 plus 20 plus 29. This keeps going on and on and on. And what we are trying to find out is S of 20. Now, what that S of 20 means is we want to find the sum of the first 20 numbers. And here's what we don't want to do is keep writing out 20 terms and then get the calculator out going, not 2 plus 11 plus 20 plus 29. That could get pretty long, especially if you're adding up like 300 numbers. All right, so we do have our formula here. And so, or S of n, well, we're in fact finding the sum of the first 20 numbers. And so that, again, would mean that our n value is 20. All right. Now, another of the same variables that we dealt with earlier today. We have our n. We need our a and our d. All right. So, again, the first term of this series is a 2. All right. Now, the only other thing I need is the common difference. All right. So I look again. What's happening here? Well, I go from 2 to 11. I'm adding 9, 11 to 20, I'm adding 9, 20 to 29, I'm adding 9. And so the common difference for each term is 9. They're separated by a difference of 9. All right, so now I have my variables, right, except for 1. So again, that's something I mentioned many times in every math class. Got to know them all but 1. And so I'm going to substitute into my summation formula over here. And so I'm looking for S of 20, the sum of the first 20 terms. My n value is 20. Now we got the square brackets. 2 times a, so 2 times 2. Plus n minus 1 right here. Well, our n is 20, so I'm going to shorten this up a bit and put a 19 there. So there's my 20 minus 1. And again, my difference here that I'm multiplying is 9. Put that in square brackets, and at the very bottom here, I got my little 2. All right, now that I've substituted in, that's the hard part. I'm just looking at doing bedmas here at this point. So inside the brackets, I have S of 20 is equal to 20. Let's see here, 2 times 2, and it was 4, plus 19 times 9. That's a weird one. 19 times 9 is 171. And of course, divide by 2. Always a good thing when things get simpler. All right, S of 20. Okay, so now I can just, in the brackets here, I have 4 plus 171. That's 175. divide by 2. And then finally, well, I can do this all in one step. I take my 20 times the 175, then divide it by 2. Let's see here. I can do that in a calculator. I can do it mental math, actually, because I can do 20 divided by 2, which is 10, then times 175. Either way, I'm getting 1,750. So that would be adding up the first 20 terms of this sequence, where it starts at 2, the difference is 9. That's what the first 20 terms would add up to. All right, let's try another one of those. Let's get rid of this. We'll leave our formula there. It's not an easy one to remember, so I'm going to need it. All right, so next up, example 2. We have a series, so again, that means we're adding these up here. So I have 45 plus 39 plus 33 plus 27 plus, keeps going. And this time we are looking for the sum, S of 10, which is the sum of the first 10 terms. All right, so we're looking at adding up the first 10 terms. So there's my n value. I want to add up a total of 10 terms. All right, now again, the other variables that we need to look at is the a and the d. And again, the a is always the easiest one. It's the first one. First letter in the alphabet, first term in the series, and that this time it is 45. All right, but then I look at my numbers here, and as you can see, they are decreasing. So my d is going to be negative. All right, and it looks like to go from 45 to 39, I'm going down 6. 39 to 33, down 6. Well, since this is an arithmetic series, I mean, it's got to keep continuing. So again, it's down 6. And so my d value, as promised, is a negative 6. Again, because my numbers are decreasing as I move through this series. All right, so now I've got my variables. I'm going to substitute into my formula here. So I'm looking for the sum of the first 10 terms. My n is 10. All right, and then in brackets, I have 2 times a, and a, this time's 45, bigger number. All right, plus, again, in the brackets, I have an n minus 1. So if my n value is 10, I subtract 1, then I'm going to have a 9 here. Skip a step there. And again, my d value is negative 6. Better put in brackets because it's 9 times minus 6, not 9 minus 6. All right, again, common errors to forget that divided by 2. All right, again, I'm going to follow Bedna's here and work inside the bracket. So I got a 10 here. 2 times 45, I know that's 90. Now I have 9 times minus 6. So positive times a negative is going to give me a negative. And that should be a minus 54. And again, divide by 2. All right, we're going the right way here because things are getting simpler. All right, now inside the brackets, I take my 90 minus 54, 36, I believe. So I'm going to have 10 times 36 and divide by 2. All right, so again, I can do this all in one step. 10 times 36 and then divide by 2. Let's see, a little mental math here. 10 times 36 is 360 because you're just adding a 0. And then take 360 divided by 2. Well, I know from geometry, 360-degree angle divided by 2 is going to be 180. And there we go. So that would be the sum of the first 10 terms for that sequence. All right, this time we had a negative or a negative common difference. All right, now we get to example 3. All right, so example 3, a fictional question because it talks about a lottery and, well, you guys are all minors, so gambling's bad, all right? You're not allowed to do it because you're under 18. Just throw that out as a disclaimer. All right, so example 3 talks about a high school in Ontario, which is going to be under litigation, has started a new lottery called Cash for High School, in which a student who wins is paid an amount of money after each month. Wouldn't that be nice? The first month, you get $20. And then after each month, the payment increases by $5. The payments for Cash for High School last 4 years. So your entire grade 9, grade 10, grade 11, grade 12 year. The lottery also gives the winner an initial choice of either taking the payments or an immediate payout of $6,500. Which would you take, the payout or the payments? All right, so you can get paid $20 for that first month, right? But then the second month, it bumps up to $25. The third month, it bumps up another $5 to $30. The fourth month, this keeps going on and on and on for 4 years, all right? Now, are we going to take the $6,500 or are we going to take the payments? So here's what I want to add up. How much would all the payments be? All right, so we're going to find the sum of the payments. Now, again, I've got my variables over here. All right, my N, my A, and my D. So here we go. Now, first off, the A is our first payment or our first term in our series. It's 20. That's your first payment. Now, the payments, as we move through this series, are always going up 5. So that would be our common difference. Now, this N value is how many payments are there going to be? And this is kind of like when we did our financial math unit. That's why we did it ahead of this one. Is that we're doing this for 4 years, right? You're getting paid for 4 years if you win this lottery, but you're getting monthly payments. So times 12. 12 payments each year, and that would be a total of 48 payments you would receive if you won this lottery. So in fact, what we're trying to find here is the sum of the first 48 payments. So we're looking at S of 48. That's why I just left that S there. All right, so just like I had before, now this is a bit of a word problem, so you had to work that out. But again, we're just going to use our formula over there. So I have S of 48. Why don't I move that over a bit here? I want some room. All right, so my N is 48. There is going to be 48 total payments. 2 times A, again, back to my variables. This is why I always like to write down my givens. 2 times 20. All right, plus, again, in the brackets, we have our N minus 1. Well, again, there's 48 payments. Minus 1. So I'm going to have a 47 there. And our difference is that each time the payments are bumped up $5. And of course, can't forget the divided by 2. All right, again, just the math doing Bedman. So inside those brackets, so I've got S of 48. I got the 48. Now here's something. I can change this up a bit of how I calculate this. Because of, I can put the 48 and the 2 together. I have a 48 on the top here and a 2 on the bottom. I divide those two. I can just get straight to the 24 there. But again, before I do all that, I got to do inside the brackets here. So 2 times 20 I know is 40. 47 times 5. Yikes. Grab the calculator here. 47 times 5 is 235. All right. Again, just continuing on. Well, I put those two together, so I'm going to have 24 times 275. All right, I multiply them. I'm going to need my calculator here. And it looks like it's going to be, let's see here, 24 times 275, $6,600. And so if the payout is $6,500, well, I've had students tell me they'll take the $6,500 because they'd rather have it in their hand right there and not wait 4 years just to get the extra 100. So again, up to you. right? But if you wait for the payments, in the long run, you end up getting $100 more. There we go. So there's example 3. Last one, little different again, a little stepping it up a bit. Kind of combining what we did this morning with what we're doing right now, right? On our last example. All right, so here we go. Find the sum of the following series. So I want to add up this whole entire series. So we have 13 plus 24 plus 35 plus the series goes on and on and on. And then our last term here is 156. All right, so that is the series that I want to find the sum of. All right, so I'm going to find the sum of this series. Now, again, we have our variables over here. So I need the n, the a, and the d. Now, I want to find the sum of this series. It's the n. How many are there? I have no idea. 13. We keep going and going, and then this means there's a lot. There's a lot of numbers being added in there. I don't know n. I do know a. The first term here is 13. Got that down. And the difference. So going from 13 to 24, I'm up 11. 24 to 35, up 11. So I got the common difference is 11. But I can't, again, find the sum of this series because I've got 2 unknowns, right? That's a problem. I can only have 1 unknown. But here's what else I do know. I know the last term. In the last term, we call Tn. It's the nth term, the last term. And so I can throw that down, and that the last term is 156. Now, if I find out which term that is, then because it's the last one, it tells me how many terms I've got. And so I'm going to use my formula from this morning, where I have Tn is equal to A plus n minus 1 times D. Now, I know this last term, or the nth term, is 156. I know that the first value, or first term, is 13. I don't know n. I don't know which term that is. So I'm going to put the n minus 1 here. Now, I do know my D is 11. Now, by using my Tn formula, and this is something we did earlier today, I believe at 9 o'clock lesson, is look at, I have one equation, and I can find that n value. All right, so I'm going to do a little bit of algebra here. So I got 156 is equal to 13. A little reverse of the rainbow rule here. So I have 11 times n. Well, that's 11n. 11 times minus 1, that's a minus 11. Okay, so now I'm just simplifying things over here. 13 minus 11, put the numbers together, I got 2. All right, still going here. So I'm going to move the 2 over to the other side. Right, it's going to be a minus 2 when it comes over, so I'm going to just put 154 here, and then I have the 11n. Okay, let's see here. Divide by 11 to get n by itself. And here's the thing with n. You can never get a decimal answer. It's like having, somebody asked me how many kids I have. I have 2 kids. I don't say I have 2.5 kids or 3.25 kids. I'm sure your parents shouldn't say that either. All right, because you're counting terms. There can't be half a term. You either have a term or you don't. And in this case, let me see. I take 154 and divide it by 11. I'm getting 14. So that is telling me 2 things. Number 1, this 156 is the 14th term. But because it is the last term, it's telling me that this sequence, this series, gotta watch my words, this series has 14 terms. So there's my n. And in fact, so when it says find the total or the sum of this series, we now know that we are looking for S14. the sum of the first 14 terms. All right, so I do a little bit of work there to get my n, but now I'm back over to my formula here. All right, so let's see, substituting my values. So I'm finding s of 14, got that figured out. My n, again, is 14. 2a, a is 13, so I'm going to have 2 times 13 in here, plus, again, n minus 1, our n is 14, so that means I'm going to have a 13 here, times my d, which is 11. There we go. And, of course, can't forget, divide by 2. All right, so, again, continuing on here, S14, just like we've done before, 14. Let's see, 2 times 13 I know is 26. 13 times 11. I want to say 133, but I don't know. Let's see here. Multiply it. 143. 143. All right, a little bit off. And, of course, the divide by 2. All right, and again, just doing the math, the bedmas. S14 is equal to 14. Let's see here. 26 plus 40. 143, you're going to have 100, 2 on the 4 is a 6, 6 and the 3 is a 9, all right? So I got 169, and again, divide by 2. And now I can do this all at once, which is great because I'm running out of room. The sum of this series, which we found out has 14 terms, I take 14 times 169, and I divide it by 2, and I'm getting a total of 1,183 is the total of that series. All right, so again, different formula. The difference between a sequence, which is just a list of numbers, a series is we're adding up all those numbers. All right, so I went through the different examples that we could have. The first one was an easier one because the difference was positive. Second one, the difference was negative. Third example we did was a word problem. And then our fourth example here, you had to use some information that we used this morning, our general term formula, as it's called, to find out how many terms were actually in this series, and then actually finding the sum of that series.